Welcome back. In this video, we are going to solve problem 7-1 that is taken from chapter number 7, Internal Forces, and book name is Statics and Dynamic by R.C. Hibbeler, 14th edition. So statement is determine the shear force and moment at point C and D. So you can see this is an overhanging beam. Clear. At point A we have a roller support, and at point B we have pin support. The loading is shown 500 pound, 200 pounds and 300 pounds respectively. So you have to find the shear force and moment at point C as well as point D. So let's start with the solution. What will be the first step? First step is that if you remove this roller support at point A, so you will be having a reaction force which will be represented as AY. Similarly, if you remove this pin support at point B, so you will be having a vertical reaction force which will be represented as BY, and there will be horizontal reaction force as well, which will be represented as Bx. So we will find this Bx, By and Ay by using equation of equilibrium. So first equation of equilibrium we will apply is sum of all moments about point B should be equal to 0, and taking the counterclockwise moment as positive. So you can see about point B as this force and this force is passing through point B, so they are not producing moment. So first moment will be produced due to this force. So this force is Ay, and the perpendicular distance is this one, which is equal to 14 feet. So, and this is producing clockwise movement, so it will be taken as negative. So I can write it as AY multiplied by 14 feet, and this is negative. The second moment that is produced due to this 500 pound load, and the perpendicular distance is 8 feet, and this is producing counterclockwise movement, so it will be positive. So I can write it plus 500 multiplied by 8. And the last moment that is produced due to this 300 pound force, and perpendicular distance is also 8 feet, and this is producing clockwise movement, so it will be negative. So we can write it minus 300 multiplied by 8 is equal to 0. So from here we will get 14 AY plus, we will use calculator, 500 multiplied by 8 is 4000, minus 300 multiplied by 8 is 2400, is equal to 0. So now 4000 minus 2400 will give you minus 14 AY plus 1600 is equal to 0. So from here this 14 AY will be equal to 1600, and from here we will get AY will be equal to 1600 divided by 14. So I will take 1600 divided by 14 is actually AY comes out to be 114.285, which will be round off to 29. So this is 29 pounds. So this is your AY. Okay. Now we'll find this Bx and By. So for Bx we will use this formula that sum of all forces along x direction must be equal to 0, and force toward right side is taken as positive. So you can see you have only one horizontal force, Bx is acting, and there is no other force, so it means that Bx is equal to 0. Okay. Now we'll find the third one, By, by using the third equation of equilibrium, and that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So one upward force is Ay, which is positive, minus 500 minus 200 plus By minus 300 will give you the sum of all forces along y direction must be equal to 0. So I will write Ay is 114.29 minus 500 minus 200 plus this By, which is upward, minus 300 is equal to 0. So from here this By will be equal to minus 114.29 plus 500 plus 200 plus 300. Clear? And when you calculate this By, so you will get again minus 114.29 plus 500 plus 200 plus 300 is 885.71. Now you can confirm it. If you add all these forces, this is 1000, and if you add Ay and By, it should be also 1000. So 885.71 plus 114.29 is 1000. So it means that Ay and By are correct. So up till now we have find out this Ay, clear, By and Bx. Now you have find it. So what we are going to do is that first we will find the internal shear force and moment at point C. So for that we will cut the beam at point C, and we will draw the free body diagram. So for segment AC, free body diagram will be, So if I draw this beam like this, so this is your point A where you have only AY, which is how much? 114.29. At this point you have 500 pound force, and that is acting at a distance of 6 feet from this point A. Clear? And this is your point C, which is at a distance of 4 feet from this load. So when you cut it at point C, so what you will have, you will be having one normal force that will be represented as NC. Clear? You will be having a shear force at this face, which is VC, and you will be having a moment, internal moment, which will be MC. So we are going to find this VC and MC by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right is positive. So there is only one horizontal force NC is there. There is no other force. So it means that NC is equal to 0. Now we'll find this VC by using the second equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So vertical forces are 114 minus 500 minus VC is equal to 0. So I can write it minus 114.29, sorry, plus, because this is upward, minus 500 minus VC is equal to 0. So VC will be equal to 114.29 minus 500. So I can write it 114.29 minus 500 will give you minus 385.7. So we will write it, this VC is 386 minus 386 pound. Okay. Since this VC shear force is negative, so it means that our assumed direction of VC, which we have taken here as downward, is wrong. It should be upward. So the correct answer will be, we have VC is equal to 386 pounds upward. Clear? This arrow sign is upward. Now we will find this MC by using the third equation of equilibrium, that is sum of all moment about point C is equal to 0 and taking the counterclockwise moment as positive. So the first moment about this point C is due to this 114.29 force, and perpendicular distance is this 10 feet because this is 4 feet. So I will write it here 4 feet. So this load into perpendicular distance is producing clockwise moment, so it will be negative. So I can write it minus 114.29 multiply by 10 feet. The second moment is due to this 500 pound force and perpendicular distance is 4 feet and it is producing counterclockwise moment, so it will be positive. So I can write plus 500 multiply by 4, and the third external moment is MC, which is counterclockwise, so it will be taken as positive. Their sum must be equal to 0. So it will give you minus 1142.9 plus this is 2000 plus MC is equal to 0. So minus 1142.9 plus 2000 will give you 857.1 plus MC. So MC will become equal to minus 857.1 pounds into feet. Since this M is also negative, since MC is also negative, it means our assumed direction of movement is wrong. It should be clockwise. This should be clockwise. Clear? So we will get this MC will be equal to 857, round off will be 857 pounds into feet, and that will be clockwise. So this is the internal movement at point C. Now what we will do is that we have been asked to find the internal movement at point D. So what we will do is that we will cut this beam at this point. Here we will have two sections. One is this one and the second one is this one. So we are going to take this section because it will be easier to solve it. So I will draw this for segment ED, the free body diagram FBD will be like this. Will be the beam. This will be your point E, and this is your point D. At point E, you can see you have 300-pound load. So we are going to take it 300-pound load downward. Here, distance between D and E is 2 feet. You can check it above. This is 2 feet. So when you cut this beam at section D or at this point, so you will be having one normal load that is acting perpendicular to this face is normal axial load. We will represent it as ND. You will be having a shear force on this face which will be equal to VD, and we will take it upward, and you will be having moment MD that will be taken as clockwise. This is due to convention, and later on we will check whether these are correct or not. Now we will apply the equation of equilibrium in order to find this. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right direction is taken as positive. Only there is one normal load that is acting in x direction, but it is opposite to this, so it will be negative, and there is no other horizontal force, so it means that this ND is equal to 0 pounds. Okay, we will find this VD by using the second equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So one load that is acting downward is minus 300 plus this VD which is acting upward. You can see we have taken it upward is equal to 0. So it means that this VD is equal to 300 pound. This is the internal shear force at section D or at point D. Now the third point is that we will find this moment by using sum of all moment about point D is equal to 0 and taking the counterclockwise moment as positive. So about point D, this force is producing moment. So this force into perpendicular distance is producing clockwise moment. So it will be negative. So I can write minus 300 multiplied by 2. And this external reaction, internal moment, which is MD, is also clockwise. So their sum must be equal to 0. So from here, you will get this MD will be equal to minus 600 pounds into feet. The value of M is negative, so it means that assumed direction is wrong. Clear? So MD should be equal to 600 pounds into feet. That will be counterclockwise. Clear? So this is the shear force at point D, and this is the moment at point D. And this was all about this problem 7-1. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. Thank you. Welcome back. Problem 7-2. This problem is taken from chapter number 7, Internal Forces, and book name is Statics and Dynamics by R.C. Hibbeler, 14th edition. So statement is determine the internal normal force and shear force and bending moment in the beam at point C and D. Assume the support at B is a roller. Point C is located just to the right of 8 kips load. So you can see this is a simply supported beam having a point load 8 kips, and there is a moment which is 40 kips into feet. So you have to determine the internal loadings, which means internal normal force, shear force, and bending moment at point C and D. B is a roller support, and point C is located just to the right side of this 8 kips load. So let's start with the solution. The first step is that if you remove this pin support at point A, so you will be having a normal force which is AY, as well as you will be having a horizontal reaction force which is equal to AX. Similarly, if you remove this roller support at point B, so you will be having a vertical reaction force which will be represented as BY. So we will find this AY, BY and AX by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right side is taken as positive. You can see only one horizontal force AX is acting. There is no other force. So it means that AX is equal to 0. Now we'll find this AY by using the second equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see AY, which is acting upward, minus this 8 kips load plus this BY is equal to 0. So from here AY plus BY is equal to 8. So both are unknown, so we will take this as equation number 1. the third equation of equilibrium that we will be using is that sum of all moments about point A is equal to 0 in order to find the By, and taking the counterclockwise moment as positive. So about point B, A, the first moment is due to 8 and perpendicular distance is 8 feet and it is producing clockwise moment, so it will be taken as negative. So I can write it as 8 minus 8 multiplied by 8. The second moment is due to this By and perpendicular distance is 24 feet and this is producing counterclockwise moment, so it will be taken as positive. So I can write plus By into 24, and the last you can see you have external moment which is also counterclockwise, and that is plus 40. So I can write it plus 40 is equal to 0. So minus 8 multiply 8 is minus 64 plus 24 By plus 40 is equal to 0. So minus 64 plus 40 is minus 24. So By will be equal to, I can write is minus 24 plus 24 By is equal to 0. So it means that 24 By is equal to 24 and By will be equal to 24 by 24, which will be 1, and unit will be kip. So we have find out this By, and the last thing is that if you want to find Ay, so put By is equal to 1 kip in equation 1. You will get Ay. So Ay will be equal to 8 minus By, and 8 minus 1 will be equal to 7 kip. So we get Ay is equal to 7 kip. So these three are the reaction forces. I will highlight them: Ax, By, and Ay. Clear? Now what we have to find is that, as we have been asked to find the internal loading at point C, so for that we will cut this beam at point C, clear, which is just to the right side of this 8 kips loads, and we will draw the free body diagram. So for segment AC, the free body diagram will be like this. Is the beam, clear. Here you have Ay, which is upward Ay, and at this point you have 8 kips load, and this is your point C. So when you cut it, you will be having a normal axial load, which is NC. You will be having shear force, which will be VC, and there will be a moment which will be MC. The direction of this MC is counterclockwise, is due to convention, and VC is also taken as downward. So we will find them one by one. So how we will find it? So for first, for horizontal force, we will apply the equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force toward right is taken as positive. So only NC is acting horizontal, there is no other load, so it means that NC should be equal to 0. Now we'll apply the second equation of equilibrium for finding VC, that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So first force is AY, which is 7 kips. So 7 kip, that is upward. This minus 8 kip, which is downward, minus VC is equal to 0. So it means that VC is equal to 7 minus 8, which is equal to minus 1 kip. So I can write VC is equal to minus 1 kip. Now this VC is minus, so assume direction is wrong. I will write it: assume direction is wrong and VC should be upward. So I can write the correct answer: VC is 1 kip, and that is upward. This is the internal shear at point C. Now I'll find this MC by using the third equation of equilibrium, that is sum of all moment about point C is equal to 0, and taking the counterclockwise moment as positive. So you can see from A to C distance is 8 feet, so this distance is 8 feet. So the first moment about this point C is due to this AY into 8 feet, and this is producing clockwise movement, so it will be negative. So I can write it: AY is 7 kips multiplied by 8, and this is clockwise, so it will be negative. And the external movement, internal movement MC, which is taken as counterclockwise, is positive, so I can write plus MC. There is no other moment, so their sum must be equal to 0. So from here we can find this MC is equal to 7 8s are 56, and the unit will be kips into feet. Since this is a positive value, it means that our assumed direction is correct. So we have find out the internal normal force, shear force, and movement at point C. Now what we are going to do is that we are going to find at point D as well. So what we will do is that for that we will cut this beam at this D, and we will take this portion for our analysis purpose, and we will draw the free body diagram. So for segment DB, we will write for segment BD or DB, I will draw the free body diagram over here. So this is the beam, clear? This is your point B, and this is your point D. And at point B, you have a vertical reaction force, which is By, and that was equal to 1 kPa load. And there was a moment, there was a moment as well, which was 40 kPa into feet at point B. Let me show you here. This is the 40 kPa into feet. And when you cut it at point D, so you will be having normal axial load, which will be ND. So you will be having a shear force, which is VD taken upward on this section, and there will be a moment that will be MD, that is taken as clockwise by convention on this right side section of the beam. Now we'll find this one by one. For first one, we will apply the equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force toward right is positive. So only one normal force, horizontal normal force, that is acting in opposite to the positive axis, and there is no other load. So it means that minus ND is equal to 0. So from here, we will get this ND is equal to 0. The second, we will find this sum of all forces along y direction must be equal to 0, and force toward upward is taken as positive. So By, which is acting upward, is 1, and this Vd is also acting upward. So this Vd is equal to 0. Both are positive, so it means that Vd is equal to minus 1 K. So minus means that our assumed direction of Vd, which we have taken upward, is wrong. I will write assumed direction of Vd is wrong. It should be downward. So our correct answer, that Vd will be equal to 1 kip, and it will be downward. Okay. Now the last thing is that we'll find this moment about point D. So for that, we will apply sum of all moment about point D is taken as 0, and taking the counterclockwise moment as positive. So distance between B and D is 8 feet. So I will write it over here. This distance is 8 feet. Now the sum of all moment about point D is equal to 0. So one load is By, and perpendicular distance is 8, is producing counterclockwise moment is positive. This 40 kPa is also into feet is also positive, and this clockwise MD is negative. Their sum must be equal to 0. So I can write minus MD plus 40 kPa plus 1 multiplied by 8 is equal to 0. So it means that MD will be equal to 40 plus 8, and that will be equal to 48 kPa into feet. So MD is 48 kPa into feet. So this was the internal normal force at point D, internal shear force at point D, which is 1 kPa downward, and the bending moment at point D. And that is all about this problem 7-2. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 7-3, that is taken from chapter number 7, Internal Forces, and book name is Engineering Mechanics, Statics and Dynamics by R.C. Hibbeler, 14th edition. So statement is 2 beams are attached to the column such that structural connection transmit the load shown. Determine the internal normal force, shear force, and moment acting in the column at section passing horizontally through point A. So you can see this is a column, and these two are the beam that are connected with this column here, here, and here. And the transmitted loads is shown here. It is 16 kilonewton. This is 23 kilonewton downward, and this 6 kilonewton and 6 kilonewton acting horizontal. So you have to determine the internal loadings or internal forces at A when a section pass through point A horizontally. So let's start with the solution. As you cut this beam at section A or a plane passing through point A horizontally. So at this point A, you will be having a normal axial load which will be represented as NA. So I will take it like this, NA, and along with that you will be having a shear force which will act horizontally, and that shear force is like this. It will be like this horizontally. It will be equal to VB, and as well as there is a moment which will act like this. There it will be like this, and this moment will be equal to MA. Sorry, this is also VA, not B, because it is passing through A. Now you have all these forces, so we will find them one by one. So starting from the first one, we will apply the equation of equilibrium, that sum of all forces along x direction must be equal to 0 and force toward right is taken as positive. So here you can see you have three forces. One is this 6 kilonewton load that is acting positive direction, so it will be plus. The second one will be this one, -6, that is in opposite direction to what we have selected, and this VA is also toward the left. Their sum must be equal to 0. So I can write it as minus VA minus 6 plus 6 is equal to 0. So from here we will get that shear force at point A is 0 kilonewton. Now we will find the second one by applying the equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see this first one, 16 kilonewton load that is acting downward, so minus 16. This 23 kilonewton load that is also acting downward, this is minus 23, and this NA is normal axial load which is acting upward, so it NA will be equal to 0. So from here you will get this normal axial load NA is equal to plus 16 plus 23, and from here you will get that NA is equal to 39 kilonewton load. Since this is positive value, it means that our assumed direction of NA is correct. Now the last thing that we are going to find out is this moment about A. So for that we will apply equation that sum of all moments about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A, this moment is MA, which is taken as counterclockwise internal moment at point A. So I will write MA. The second moment is due to this load, which is 16 kilonewton load, and you can see the perpendicular distance between this load and this load is this one, which is 30 plus 125, which is 150, and 150 millimeter is actually in meter, it is equal to 0.150 meter. So I will show you this load into perpendicular distance. This is producing counterclockwise movement, so it will be taken as negative. So I will write it, sorry, this is not 150. 30 plus 125 is 155. So make it correct. This is 155. So 155 millimeter is actually 0.155 meter. And I will write this is producing counterclockwise movement, so 16 multiplied by 0.155. Now the second moment is due to this 23 kilonewton load, and perpendicular distance is this one, which is 40 plus 125 is 165, and 125 plus 40 is 165, and 165 is 0.165. So I will write 23 multiplied by 0.165 meter, and you can see that this load into perpendicular distance, this is producing clockwise movement about point A, so it will be negative. The last thing is that you can see this 6 kilonewton load that is acting horizontally, they are non-collinear force and they will produce couple, because these forces acting in different plane and in opposite direction, so it will produce couple or rotating movement, so this will be negative. So I can write it as this will be minus 6 multiplied by perpendicular distance between them is 185 millimeter, which is 185 meter, and their sum must be equal to 0. So I will calculate one by one. 16 multiplied by 0.155 is 2.48 minus 23 multiplied by 0.165. This is minus 3.795, and minus 6 multiplied by 0.185 is minus 1.11 is equal to 0. Now 2.48 minus 3.795 minus 1.11 will give you 2. MA minus 2.425 is equal to 0. So here we will get this MA will be equal to 2.425 kilonewton into meter. So what we are getting is that you are getting internal shear force, internal normal force, and internal moment at point A, which are the answers of our this required problem. And with this, it was all about this problem 7-3. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon. And if you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 7-7 that is taken from chapter number 7, Internal Forces, and book name is Engineering Mechanics, Statics and Dynamics by R.C. Hibbeler, 14th edition. So statement is determine the internal shear and moment acting at point C in the beam. So this is a simply supported beam having a triangular load starting from A till C and magnitude of 4 kips per feet. So you have to determine the internal shear force and moment acting at point C. So let's start with the solution. The first step is that if you remove this pin support, so you will be having a vertical reaction force which will be AY, as well as there is a horizontal reaction force which will be AX. Similarly, if you remove this roller support at point B, so you will be having only vertical reaction force which will be BY. So first we will find these reaction forces and then we will find the internal reaction, internal shear force and moment. So for that I will apply the first equation of equilibrium is that sum of all forces along X direction must be equal to 0 and force toward right hand side is positive. As there is only one horizontal force AX, there is no other force, horizontal force, so it means that AX is equal to 0. Now we will find the another vertical reaction BY. For that I will apply equation of equilibrium that sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A, the first moment is produced due to this BY force and perpendicular distance is 12 feet and this is producing counterclockwise moment, so it will be positive. So I will write BY multiplied by 12. Now you can see this is a triangular load. So triangular load when converted into a point load, so we will convert it by using this formula 1/2 its magnitude which is 4 and total length over which it acts is 6, and that will be 24 divided by 2, it will be 12 kip. Okay, and that will act at a distance of L by 3 from this side, from this higher magnitude side. So L is 6, 6 by 3 is 2, so 2 feet from this side, and the remaining will be 4 feet. Okay, so the moment produced due to this force will be 12 multiplied by perpendicular distance is 4 feet, and this is producing clockwise movement, so it will be taken as negative. So minus 12 multiplied by 4 is equal to 0. So 12 by minus 48 is equal to 0, and 12 by is equal to 48. So dividing 12 on both sides, so we will get by will be equal to 48 divided by 12, and this will give you 4. 4 unit will be kip. You have this vertical reaction force. So now we'll find the last one by using the equation of equilibrium that sum of all forces along vertical direction must be equal to 0 and upward force taken as positive. So AY, which is unknown, is upward, minus this 12 kips load which is downward, plus this 4 which is upward is equal to 0. So from here AY minus 8 is equal to 0. So it means that AY is equal to 8 kips load. Okay, now we will move toward finding internal load at point C. For that we will cut this beam at C. So you can see you have one section on the left side and another section on the right side. So if you take any of this, you can find the internal loading. So I will choose the second one because it will be easier to solve. So take segment BC and draw free body diagram. So if you draw the free body diagram, so it will be like this. This is point B, this is your point C. At B you have only vertical reaction force BY, which is 4 kip. Clear? And when you cut at point C, so you will be having a vertical reaction force which will be equal to VC, and you will be having moment at point C which is internal moment which is MC. So we will find this VC and MC by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along Y direction must be equal to 0 and upward force is taken as positive. So VC, which is upward, plus this BY, which is 4 kips, is also upward. Their sum must be equal to 0. So it means that VC will be equal to minus 4 kip. Okay, this means that our assumed direction Minus means it means that VC should be downward. So our assumed direction which we have taken upward is wrong. So VC should be downward. So I can write VC is equal to 4 kip and it should be downward. Or you can also write it that VC is minus 4 kip. Now we'll find the moment. So for that we will take sum of all moment about point C is equal to 0 and taking the counterclockwise moment as positive. So about point C, the one moment is by into perpendicular distance, this which you can see is 6 feet. This is 6 feet. So let me write it. This is 6 feet. And this force multiplied by this perpendicular distance is producing counterclockwise movement, so it will be positive. So I can write 4 multiplied by 6 minus this MC which is taken as negative clockwise, so it is equal to 0. So from here we will have MC is equal to 24 kip into feet. So this is how we have find out this internal shear force at C and moment at C, which are the answers of our this question. And this was all about this problem 7-7. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.